Welcome back to our sixth video in our series on Basic SQL. SQL being the standard query language or structured query language of relational databases that serves the functions of data definition language, data manipulation language. In general, it's just an all-purpose scripting language for relational databases. Referential integrity is specified via the foreign key clause. A referential integrity constraint can be violated when tuples are inserted or deleted, or when a foreign key or a primary key attribute is modified. The default action that SQL takes for an integrity violation is to reject the update operation that will cause a violation. This is known as the restrict option. In fact, I don't see restrict on our slide here, so why don't we just make restrict our mystery word for this video. The restrict operation is the reject update on violation action. However, the schema designer or the database designer can specify an alternative action to be taken by attaching a referential triggered action clause to any foreign key constraint. The options include set null, cascade, and set default. If the action is defined in a statement, it must be qualified with either an onDelete or an onUpdate qualifier. Let's see how this is implemented in MySQL. Here we are at MySQL's website, and this is the section on foreign key constraints. Let's go down here and see if we can find an example of a script. Here you go. Examples of foreign key clauses. See, we're defining two tables. As you can see, this is just an example. Table parent, table child. It could be table employee and create table dependent. In any case, when the parent table is created, the statement create table in parent, whatever that parent table name happens to be, open paren, and we're defining the attributes. Here's ID, integer, not null. Obviously, you would have more attributes than this. And then after the attributes are defined, the primary key is defined, primary key ID that you see there. And then you have the closing paren. Next, we're defining the child table. So we create table child, open paren. It also has an ID attribute. Now we're using the same name to represent a different value in a different table. And that's okay. And we will see how to address that in queries where both of these tables are being called up, and the fact that there are the two fields in two different tables with the same name could potentially cause us a little inconvenience, but there's a way around that, and we'll discuss that later. In any case, we define the child table. There's ID, that's the primary key in that table, and then there's another attribute, parent underscore ID, which is an integer, which I'm sure will be the foreign key attribute linking it to this table up here. This is defining an index. We'll talk about that at another time. And here is the foreign key definition. Foreign key, open paren, parent underscore ID. So it's basically defining parent ID as a foreign key, and the statement continues, references parent, here's parent, the ID attribute up here in parent. So the complete statement says foreign key, open paren, parent ID, there it is, references parent ID, onDelete cascade. That is the entire line. And that onDelete cascade is overriding the default action when an integrity violation occurs when a foreign key or a primary key is altered or deleted, actually canceling the operation. In this case, if it violates that integrity constraint, it will delete not only the record up here, but it will come down and delete all the other related records in the child tables. That's what cascade means. That's one of those statements you got to be careful with. So there you go, an example. Let's take a look at this statement, foreign key, open parent. That's a legal statement right there. The structure is legal. But we could modify it by putting the statement constraint in front of that and then a constraint name and then continuing this. In this particular example, they do not give the constraint a name. Okay, well, let's go back to our slide. Take a look at this one. Creating table employee, and they're defining a foreign key constraint. This one they're giving it a name, constraint imp super foreign key. And here's the statement, foreign key open super SSN, which is the social security number of the supervisor. References the employee table, and it says, continues, on delete, set to null. On update, cascade. So if this action violates an integrity constraint, if it happens to be deleting, it will change the value to null, which is a legal value for a foreign key attribute. If you put any value in an attribute that's defined as a foreign key, it has to match primary key in the parent table. However, you can leave it null. So in this particular instance, they're saying on delete, just set it to default, which would be null. On update, if we modified the value, it would update all of the related tables. Here's another one, and this one is doing the same thing. We got a foreign key manager SSN referencing the employee table SSN, and on delete it says set it to default, so it will put a null value in there. And on update, it will cascade. It will update that same value in all related tables. What do we see as our potential problem with this table definition right here? We're defining the table employee, and the constraint that defines the foreign key right here, foreign key SSN, is referencing the very table that we're creating, which means this action won't work. We would have to leave this out and come back after this table were created and then alter it to add that constraint. A constraint may be given a constraint name following the keyword constraint. The names of all constraints within a particular database must be unique. A constraint name is used to identify a particular constraint in case the constraint must be dropped later and replaced with another constraint. Giving names to constraints is optional, but it is considered a good idea. In addition to key and referential integrity constraints, which are specified by special keywords, other table constraints can be specified through additional check clauses at the end of the create table statement. These can be called tuple-based constraints because they apply to each tuple individually and are checked whenever a tuple is inserted or deleted. Here we see an example. Now this would be at the end of a create table statement at the bottom when you are defining various constraints. We have a check constraint, which is basically saying that department create date must be less than or equal to the manager's start date. Okay, that was a pretty good bit of material right there, so why don't we go ahead and take a break, submit your mystery word, and when you're done, go out to our course website and check your knowledge on this video. And when you're done, come on back for the next video in this series on Basic SQL.